Hi, a very happy morning, students. We have come back in a very fresh manner. We'll be continuing with the second lesson, collection of data and sampling methods. We are looking into sampling methods, and today we are going to see stratified random sampling. How the stratified random sampling method is going to be useful in population studies. Okay. Now, stratified random sampling. Now, we have the heterogeneous population. The heterogeneous population of size n units. Now, this n unit is heterogeneous population of size n unit. The size of the population here we have taken as n units. It is subdivided into L, that is homogeneous non-overlapping subpopulation. Okay, that is what is called as strata. Okay, so now we are going to see the stratified random sampling. Heterogeneous population of size n units. The size that we have taken is n units. It is subdivided into L, that is homogeneous non-overlapping. Non-overlapping means it should not overlap, isn't it? We cannot have a definite picture. So, non-overlapping subpopulation, the population which is subdivided, that is called as strata. So, you know what is strata. So, stratified random sampling. The strata, this is the strata, and this strata will be random will be used for random sampling. That is why it is called as stratified random sampling. Now, the ith item, stratum having n1 units, that is I will be 1, 2, 3 up to L. Okay, such that n1 plus n2 plus nl, that will be n. So, we are calculating it as n1 plus n2 plus nl up to nl, and that will be as n. Now, the heterogeneous population, we'll draw it as a table here. Okay, we'll do it as a table. Heterogeneous population, the population is being subdivided, isn't it? Homogeneous subgroups. Now, the stratum size is 1. Okay. 1, stratum 1, the size of the stratum is n1, stratum 1, stratum 2, stratum L. See here, n1, n2, nl. So, stratum size is 1, stratum 1, stratum 2, stratum L. Now, the subgroups is size n1, n2, nl. Now, a sample size being ni from ith item. Okay, so ith stratum. Okay. So, ith stratum, that I will be 1, 2 and up to L. So, that will be independently taken, that will be taken out independently by simple random sampling in such a way that n1 plus n2, that will be up to nl. A sample obtained using this procedure is called as stratified random sample. We saw what is strata and what is random sampling, stratified random sampling. So, strata is nothing but it is which is subdivided and it is non-overlapping. Now, next one is what is the sample obtained using this table, say homogeneous subgroups, then stratum 1, stratum 2, stratum L. And the subgroup will be n1, n2 and nl. Using this, a sample obtained using this procedure, this is the procedure. This procedure in a table, we have written it in the table. That is called as stratified random sampling. So, we know what is strata and what is stratified random sample. So, determine the sample size of each stratum. Two methods are used. We are going to use two methods. Okay. One is proportionate allocation method. Proportionate means you are proportionating. If this is this and this has to be like this, like that, in proportion with 1:2, 2:3, the ratio, the proportionate ratio. So, proportionate allocation method. So, for what we are going to have this method? To determine sample size of each stratum. Okay. To determine that, two methods are used. One is proportionate allocation method, then is optimum allocation. Optimum is nothing but maximum. Optimum allocation method. So, proportionately we are going to calculate, then maximize, optimum allocation method. Now, first we will see what is proportionate method. Proportionate allocation method is the sample size is determined in proportion to the size of the stratum. You have a size of the stratum, accordingly the population size of the population is determined. Sample size, the sample that we are taking, isn't it? We have a sample size of population. So, sample size is determined as proportionate to the size of the stratum. So, size of the stratum and sample size will be in proportion with each other. For example, if the stratum is large, when the stratum is large, then automatically the representation of the sample size also will be large. If the stratum is large, that stratum will get more representation in the sample. Okay, it will get more representation. In the same way, it is vice versa. If the stratum is small, that stratum will get less representation in the sample. Okay, so that is what is called as proportionate allocation method. If the sample is large, based on the sample size, size of the stratum will be there. Sample size and size of the stratum will be proportionate with each other. While allocating, it will be proportionate. So, if the stratum is large, then automatically what will happen? That stratum will get, that stratum, which stratum, when the stratum is large, that large stratum will get more representation in the sample. And if the stratum is small, then it will get less representation in the sample. So, both are proportionately allocated. The formula for sample size for ith stratum can be determined using this formula. Now, Ni is equal to N by capital N into Ni. Okay, this is the formula that is being given for the proportionate allocation of stratum. Okay. Now, next one will be optimum allocation. Optimum allocation is maximum allocation. This optimum allocation method is used in variation in the stratum, variation of the stratum, and cost to determine the stratum sample size Ni. Okay. Now, this optimum allocation method is being used variation in the stratum, STRATUM, and cost to determine the stratum sample size Ni. Okay. Now, we will see this stratified random sample with an example. To study about, say for example, you are going to study 3 different schools. You are taking into consideration 3 different schools. Study about the introduction of NEET exam. What is the, how this NEET exam is going to be useful. Introduction of NEET exam, opinions are collected from 3 different schools. You are going to collect the opinion from the same area, 3 different schools, you are going to collect the opinion. The strength of each, then we have to calculate, isn't it? First we have to find out what is the strength of each school. The strength of each school is, first school is 2000, second school is 2500, third school is 4000. Okay. So, you are going to find out the opinion of NEET exam, whether NEET exam is needed or not. Why it is introduced. Do you want that NEET exam or not? Like that. So, introduction of NEET exam, opinion you are going to collect from 3 different schools, 1, 2 and 3. One is 2000 with the strength of 2000, second one is 2500, third one is 4000. So the fixed sample, now for that the fixed sample is for each, from each you are going to select 170. The fixed sample is 170. Now what we have to calculate? We have to calculate the sample size of each school. Okay. Now the school strength is being given, then the fixed sample is given. You have to calculate the sample size of each school. So n is equal to, this will be the strength, 2000 plus 2500 plus 4000, that will be 8500. So n is equal to 8500. This will be 2000 will be n1, 2500 will be n2 and 4000 will be n3. Okay. Now this n, small n is fixed sample, that is 170. Then n1 is equal to n2 is equal to n3, that is what we are going to, what is n1, what is n2, what is n3, that is what we are going to find out. So n1 is equal to small n by this n by n, that means 170 by the total strength 8500 into the first school, that will be 40. N2 will be 170 by the total strength into next 2500, that will be 50. Next one, N3 will be 170, that is the N, then by the total strength into the N3. Okay, 4000, that will be 80. So stratified random sampling method, school 1 will be 40, school 2 will be 50, school 3 will be 80. This is what is stratified random sampling. So this example for the stratified random sampling is for age, for finding out the age, sex, marital status, etc. That will be the criteria. Okay. So stratified, to determine the sample size of each stratum, two methods are used and we have seen the example. Now using this criteria, age, sex and marital status can be, that will be the criteria for finding out these strata. Okay. Now the merit is, merit means the advantages, it will be very, very clear. Stratified sampling method, it will be, random sampling method will be very, very clear and it is very precise also. Whereas demerit, accuracy is not there. Okay. Accuracy will be less. But if you want it very, very accurately, then we cannot have this stratified random sampling method. So with an example, it's being explained. Next we are going to see systematic sampling. What is system? System is one after the other, you are sequencing it, isn't it? So you make it systematized, you make it one after the other, you create a system. So systematic sampling will be systematic, one after the other, step by step, like that. So systematic sampling. First one, in this population units are numbered from 1 to n. We are doing the population studies, isn't it? So population units are numbered from 1 to n in ascending order. See as ascending order. You are numbering it, isn't it? It is being numbered from 1 to n in ascending order. Now, a sample interval is denoted. Interval means a gap between 1 and 2. Okay. So, a sample interval is denoted and it is determined as this, n by n. Okay. Now, n is equal to required sample size. This small n is required sample size and n minus 1 is sampling interval. I told you first we are going to see a systematic way, isn't it? First it is n is equal to required sample size and n minus 1 is sampling interval. So, a number is selected at random from the first sampling interval. You have a sampling interval. From the first sampling interval, a number is selected at random because we are seeing systematic sampling, isn't it? So, a number is selected at random. Okay, from where? From the first sampling interval. N minus 1 is the sampling interval. So, from the first sampling interval that is selected, that is I, where I is greater than or less than. Okay, so it is the random starting point for the whole selection of the sample. This will be the starting point for the whole selection of the sample. So, from that only this will be started. It will be the starting point. Now, sample interval you have 1, 2, 3, 4 like that. So, the whole sample is selected automatically at regular intervals 1, 2, 3, 4 like that. All the samples are selected automatically. So, systematic sampling is at regular intervals. The samples are being selected. So, you have the required sample size and the interval. Then the sample interval is 1, 2, 3, 4 like that. At regular sample interval, the whole sample is selected automatically, isn't it? So, the merit of this is simple and very, very convenient. It is very simple. You have a sample size and you have the regular interval and you find the, okay. So, it is very simple and convenient. Second one is less timing is used. This is being used for definite population, a finite population, definite population. So, it is used for a definite population, very within a very short and very limited time it is being used. It is simple and convenient. But everywhere you have the limitation, even though it is systematic and it is easy, simple, convenient, you have the limitation for it. You can call it as demerit also. Because it is quasi-random sampling, the sample may not be a representative sample. Because it is a quasi-random sampling, okay, it is, it may not be, you cannot say it is not, it may not be a representative sample, okay. So, that is what is systematic sampling. Now, next is non-probability sampling. It is selected on the basis of subjective judgment. You are judging something, the person who is conducting, that is, who is the researcher, who is going to do the research, sampling research, that person's judgment. So, subjective judgment of the researcher. So, it is selected on the basis of the researcher's subjective judgment. That is why it is called as non-probability sampling rather than random selection. How it is selected? Based on the subjective judgment of the researcher, the person who is doing the research, or the investigator, the person who is doing the investigation will select the samples on the basis of subjective judgment of himself. So, rather than the random selection. There are 4 types of non-probability sampling. There are 4 types are there. One is convenience sampling, judgment sampling, quota sampling and snowball sampling. There are 4 different sizes are there or different methods. Okay, 4 types of non-probability sampling. In non-probability sampling, there are 4 types. First one is convenience. Convenience, at the convenience of the person who is doing the research. So, convenience sampling, the sample is being taken on his own convenience. So, sample. So, A is convenience sampling. Now, sample is drawn at the convenience of the investigator or the researcher. The person who is doing the investigation or the research, on his basis, on his convenience, the sample is drawn. The sample is drawn on the basis of the convenience of the investigator. Now, in this also you have the merits and demerits. Merit is useful for cost benefit. It is very, very convenient for as a cost benefit. It is, the cost is very, very less. So, the cost benefit, useful for cost benefit. Okay. The sample is drawn on the convenience, isn't it? So, the cost benefit is also very, very convenient. So, the merit is convenient usage or convenient cost benefit. Next one is demerit is risk or misleading. Sometimes it could be misled by something. Okay. And he is taking a risk. Okay. So, it could be misled or risk taking. So, there are 4 types, out of which we are saying the first one. So, what is the first one we are saying? Convenience. Whose convenience? The investigators or the researchers' convenience. Next one is second one, judgment. Judgment, again, whose judgment? The person who is conducting the research, the person who is making the taking the samples. Okay, the person who is doing the investigation, his judgment. Okay. So, investigator believes in his opinion and his own judgment. He decides, whatever he is deciding, that would be the sample, that would be the opinion. So, the investigator believes his opinion. That is why hand picking sample units, hand picking sample units. Okay, hand picking, he selects for himself, hand picking selection unit or sample unit. Okay, he's selecting, he is the sole authority. The investigator or the researcher, he decides. The judgment is final, we say, isn't it? Final judgment. So, whatever he is taking, especially when you conduct a elocution competition or any kind of competitions at school levels, then automatically you know which boy, say for example, quiz competition is being conducted. The person who is going to conduct the quiz competition or the person who is going to select the sample would know which person will be very, very good in this quizzing. If that is selected, when they go out and further fine tuning, after further fine tuning, they will win a prize and come for the school. Like that he will also know. So, hand picking sample units. Example, quizzing or any contest, cultural programs or anything that he will select that on the basis of his own judgment. So, second one is, first one is, what is the first one? On the basis of convenience sampling. Second one, on the basis of judgment of both of the researcher, that is the investigator. Next one, the merit of it is low expense as usual. It is very, very easy to identify also. So, immediately it is easy for identification and finally the result will also be good. But demerit, if highly subjective and biased, sometimes the team would be very much in favor to the investigator. So, it is biased and highly subjective. So, out of 4, first one is convenience sampling, second one is judgment sampling. Now, we are seeing non-probability sampling methods, isn't it? Next is quota sampling. Population is divided into different groups and the interviewer, the person who is going to conduct the interview, will assign the quotas of each group. So the quotas will be assigned by the interviewer to each group. This person will belong to this group, this person, like that. The selection is based on his judgment, the interviewer's judgment. Okay. Now, this is going to be very, very easy method of non-probability sampling because the probability of selection is not there. So, it is non-probability, isn't it? So, in the case of non-probability, what will happen? This, when you take up this quota sampling methods, say for example, now we will take up the cricket team. The person who is going to allocate Indian cricket team, isn't it? The manager will allot the persons. Now, you need batsman, bowler and the wicket keeper. Okay. So, 3, it is in 3. So, batsman, say for example, we have taken into taking an example of batsman. That is at the discretion of the person who is going to select it, interviewer. Okay, 5 batsmen he is taking, bowlers 4, face bowlers or whatever it is, depending on the bowling techniques and the bowling efficiency of the bowlers. The bowlers are 4. So totally 10 people have to be selected, isn't it? So 5 batsmen, 4 bowlers and 1 wicket keeper. Like that, the groups are allocated, the quotas are allocated, and based on that, the selection is being done on the basis of the judgment of the person who is going to make an interview or who is going to make the research. So this is, cricket team is the example for this quota sampling. Okay, next one is snowball sampling. Next is called as snowball sampling. And one small and easy thing is, in this quota sampling, the merit, for each and everything we are seeing the merit, isn't it? Before we see this snowball, we will just see what is the merit of that. It is very, very quick, faster. You can make it very, very fast, then easy and cheap. But again, the demerit is, it's going to be biased. If you like, then it could be included, because the final judgment depends on the researcher or the investigator. Now coming to the snowball, the initial group of respondents are selected, first come first served. Okay, so the initial group of respondents are selected. That is because it is also called as chain referred sampling. Okay, chain referral sampling, because it is a continuously one after the other, one after the other. Say for example, this is a very, very important sampling method, because drug abusers or sex workers, for all these people, they won't come forward, isn't it? They won't come forward. Drug abusers. So once one person is being caught, or one person is being identified of drug abuse, immediately he will say, for example, now A is the person, and A person, he is going to be identified as drug abuser. Then automatically he will say, no, not only me, him, B. Not only him, the B will say, C, yes, C. Then again, chain, like a chain, it will go on and on and on. The B will say, no, we are 5 of us, D, E, F, like that. And the C person will say, no, G, H, I, like that. So, A, B, C, D, E, F, G, H, I. One was identified first. Nearly 10 people or 9 people are being identified as chain reaction. Okay. So, like that, it is chain referral sampling. Why? Because one is only, if one is identified, then automatically step by step everybody will be identified, okay, by the researcher or the investigator who is going to make a investigation.